There you go, you're going to miss the first bit of this lesson. Not to worry. You don't want me to start again.
No, it's fine.
It doesn't make sense anyway. So.
Doesn't make sense. All right. So all of these will go through 1-1. And again, x can't be 0 because if it is, you end up with 1 over 0. So what you end up with is something going like this. Now if we want to compare that to 1 on x, so this one here is x to the minus 1 on n. If you want to compare that to 1 on x goes like this.
Does that intersect the y-axis anywhere?
No. No.
So does it just stop at
Well,
the y-axis?
no, it's
Or is that-
an asymptote, but
Ah,
it swings around quite quickly.
So it's just no, it's not steep.
Shallower.
So it's kind of similar sort of shape, but goes like that. Now, if any is odd, excuse me, we can have it here and here. So if n is, when n is odd, so for odd roots, we can have excuse me. So the cubed root of -8 is -2. Cubed root of 8 is 2. So for odd roots, we can find the odd roots of negative numbers. So we end up with 2 parts. So the graph. One of them is there, and the other one is here. Like so. All right, so domains and things like that. So the one on the right here, our domain is positive real numbers. The one on the right here, our domain is everything except 0, which we can say real numbers excluding 0. Right, asymptotes, this is what you were asking about before. There are 2. It's a vertical one. Is the y-axis. Or x equals 0, whichever one you prefer to use. And the horizontal one is the x-axis. Y equals 0. All right, and that's the same, same for all of them, as for both of them, I should say. All right, excuse me. Now, there's another thing called odd and even functions. Have I defined odd and even functions? We have. I'm sure we have. Ages ago.
Yeah, we've done.
Yeah. I'm going to define it again. So this one here is neither odd or even. And so, excuse me, what that means is that for odd or even, you look at x and then you look at negative x and you see whether your graph is related. So because they're here, the positive x's down in the negative x's, there's no graph here for us to compare, then it's not odd or even. Whereas this one here, the positive x's, we've got our y value is positive. This shape is the same, but for the negative x's, the y values are negative. Right, so because that is the case, it's an odd function. So an even function would be up here, where you get the same y value for positive and negative x's. Right, so positive x's give us positive y's, negative x's give us negative y's, so that's what's defined as an odd function. Since when we put the negative x's in, we get the negative of what we had when the positive x is going. All right. Okay, so we can transform them and draw graphs, so let's do that. All right, to rubble that off.
Not the bottom bit.
Not the bottom bit. So when we sketch this, we do the same kinds of things that we did before. So this 3 here would be a dilation, and this would be a right. So because it's even, it's going to look like this, and it's going to be moved down and stretched. All right. So if it's been moved down, its horizontal asymptote will be where? Yep. Y equals -1, and our vertical is the same. X equals 0, the y-axis. All right. So if it's been moved, I'll get rid of all this now.
Yep.
So if it's moved down 1 and So we've got horizontal asymptote here, a vertical asymptote here. Question is, will it or will it not cut through either of these axes? It should cut through the x-axis, shouldn't it? So, when we have got intercepts, we should figure them out, and we'll use this dilation when we're working them out. And so that'll give us points, which will be fine. So our x-intercept is when y equals 0, so 0 equals add 1 divided by 3. This negative, of course, means 1 over x to the quarter. Both 1 over, flip both sides. If I flip both sides, I get 3 equals x to the quarter. So to get rid of this quarter, I need to do
Times, no.
power of 4, yeah. So it's like, it's the fourth root, isn't it? Fourth root. So the opposite to the fourth root is the power of 4. Just like when we square root, got something that's square rooted, we'd square it, wouldn't we? So power of 4, so 3 to the power of 4. I'll write it. Oops. Alright, so it's like that. That index law, when we multiply these two, don't we? Alright. Then 3 to the 4 is 81. So we've got an intercept down here, 81. And so our graph would look something like this. All right, any questions about that? Yes, Ethan.
In like the first line where you took away.
Added 1,
Yep.
then divided by 3.
Okay. No worries.
That's what you're after?
Yep.
Anything else? No. All right. Now, the next type of graphs that's in the study design is these.
This looks gross.
These ones are very funky.
Is this still subject?
Yeah, 7A, but it's just a different subject.
See where there's no.
All right, so then we complicate things a little bit more by the 1 at the top having another number at the top. So when Q is even, again remembering that x to the 1 on Q would be the qth root of x, and if it's x to the p on Q, it would be the qth root of x, x to the power of p. So, excuse me, and so if Q is even, we've got the same thing as I've mentioned before. You can't have negatives in there. So if Q is even, we only get a graph of positive x's. So we get a graph that looks like this. goes through 1, 1, and it's like part of a parabola like that, and depending on what these numbers are, is how much, how much it curves. But what we do have is we have a domain, which is R positive, and also 0. 0 is okay in this case. Now, when Q is odd, all sorts of stuff happens. Because there's lots of combinations, so it becomes complex. Depends on if P is odd or even. And also the ratio P on Q depends on whether that's between 0 and 1, or if it's greater than 1. So what I've done is I've prepared a handout which has got examples of all the combinations.
That's a lot of combinations.
There's 8 combinations altogether.
That's gross.
How long? How long is a piece of string?
Very short.
We're probably nearly halfway. About halfway through.
Method
The
for
theory.
just small.
Alright, so when you have a look at that, you can see there's quite a few different combinations depending on. So on the front page, we've looked at this here where P over Q is a fraction between 0 and 1. And so you can see that there's a little bit of a pattern.
Is that for if it's odd? Oh, yeah.
Alright, so you can see they kind of look like root graphs. This one down the bottom, where they're both odd, looks a bit like a cubic on the side, yeah? Alright, so that looks like a cubic on the side. These others look like parts of parabolas or root graphs. When you go over the page is this variation here, P over Q is greater than 1. And again, the one down the bottom where they're both odd, again looks like that cubic kind of graph. The top two look like part of parabola, and the bottom one here is kind of a parabola kind of a shape. Technical term there, yes. Question.
What happens if pair of Q equals 1?
F equals 1, you just get a straight line. Because it's then to the power of 1. It's x to the power of 1. So it's f of x equals x, it's just y equals x. So that's why 1 is not included in. All right. So it can be complicated. I've single-sided that so that you can put it in your bound reference. All right. So I just want to define odd and even functions again while we have done them. If it slipped my mind, it probably slipped other people's minds as well. So let's just define them and then that's done today. So odd and even functions.
We have what?
Subs for the rest of the
Where's
day.
basket?
Not yet.
Where's the English teacher?
You did know. Why am I?
Yeah.
Miss Doyle's not coming. She's sending someone else because I'm just doing the stack. So.
So much for this aspect.
Did you know Miss Dora really cares about it?
I feel like she cares about a small group of the class and just dislikes the rest.
Unlike me, that I care about everyone.
Exactly.
Oh.
Mr. Sinnott shares
Yeah,
the
we
we
have
have
that.
guests.
I've got plenty of love to share.
Mr. Sinnott has like all the controlling power.
Who's Hunt? Hunter. We have Mr. Hunter.
No, we have
No.
this Hunter.
Miss
It's
Hunter.
Miss Gemma Hunter.
Gemma.
Gemma.
Yeah.
Is his name Gemma?
We had
One.
Wait, this is.
I don't look at the last name. No, it's got
All right.
It's Miss Doyle.
It should be like one stage,
Ah.
the other live
Please
one.
don't drop spelling.
Where you die.
What's she what? Did you just say she's brown?
Don't worry about it. I wrote it red hair, brown hair.
Okay, so just formalising what I said before about odd and even functions. So it's an even function. If when you put negative x's in, the answer you get's the same as if you put positive x's. So parabola or similar. All right, so
This year
So something like this, for example, is an even function. All right, you stick your positive x values in, you get a positive y value. Stick negative x values in, you get the same positive y value. All right, so it's also got to be symmetrical, even though that one might not look like it. So that, say, for example, is x squared. Another example of something that might be an even function, something like this. X to the 2/3. Looks like that. That would also be an even function. Stick positive x values in there, you get the same y value if you stick the negative x values in there, so it's an even function. All right, so the odd functions would be if this bit was down there, and then if this bit was down there. So odd functions.
It's more than a lot of
And when you stick the negative x's in, you get the same value but negative than if you just stick the positive x's in. So what do they look like? They'd be like cubics, things like that. Got a couple of examples. Alright, so there's a cubic. That one is. And something like this, what's that, 7/5. Next to the 7/5, that would be as well.
How is that spelled? Any different?
Well, the difference between this and this will be, you know,
Stretching.
all right, but anything that's kind of like that would be,
Where would exponentials fit?
exponentials would be neither.
Would something like x to the power of -1/3 be odd function?
Power of -1/3. No, -1/3. No, 'cause you only get part of that. So things like this that don't fit the criterion are not. So exponentials is something that doesn't. So what functions, and there's probably lots of functions that don't.
Everyone.
Actually, -1/3. Yeah, it would be.
Yeah, 'cause the one we just did before.
Yeah, so that would be. Where is it? -1/3. I've forgotten it.
But just like hyperbolus as well.
Hyperbolus would fit that.
Would it be an odd function, you know, if it was -1/3?
But something like this, for example.
So if a cubic function doesn't pass through 0, is it still an odd? If it like translates?
No.
No.
So yes, they have to. Because if you've got, a good question, see? Because if you've got a cubic function that goes through here, if I take that number there, so say it goes through 2, it's been translated, I'll take that number there, 4, and then I'll take -4,
Whatever, isn't it the same?
the y values are very different, aren't they? So that's neither, isn't it? So like I said, there's many more functions that would be neither than ones that are odd and even. Good question. All right, so some examples of something that's neither. So something that looks like this. So square root graph. Something like these things that we're looking at before. One that goes like that, that's fx 7/2, or 3/2. And then Nicole's question was about exponentials. And so an exponential goes like this. So again, the same. So if we've got 1 there, then we need to look at -1. And they have different y values, so it's neither. So the y values have to be the same size. And the negative ones, like this one here, the y value is the same size, but that might be, say for example, on this is x cubed, that's a 2. 2 cubed is bad scale, 8, and -2, it's -8. So the y value is the same size, but negative. All right.
And also functions that don't pass through 0.
And ones that don't pass through zeros is that example before that Zeke brought up, yeah. Because when you put that, that's these negative x and x, that's what we're comparing. Put them in the function, do we get the same answer? Or this one with the negative, of course. Get exactly the same answer, they're positive, if we get same size but one's negative, then they're odd. And then, yeah, if they're different, they're neither. And so there's going to be many, many more functions that are neither. For these ones here, if I go x equals 2, x equals minus 2, well, there's nothing there. Compare. Right, anything else? Okay, that's 7A then.